At 6:15 a.m., November 2025, 15 Ukrainian drones began a journey that would change how we think about modern warfare. They flew 960 kilometers through Russian airspace, dodging million-dollar missiles with equipment that costs less than a used car. Their target was Ust-Luga, Russia's largest Baltic port, a facility the Russians believed was completely untouchable. What happened next reveals something extraordinary about the future of conflict. This wasn't just another military operation, it exposed a fundamental shift in how wars are fought. Ust-Luga sits on Russia's northwestern coast, right where the Baltic Sea meets the Gulf of Finland. This port handles 650,000 barrels of oil every single day, which accounts for roughly 20% of all Russian oil exports shipped by sea. When you factor in natural gas, liquefied petroleum, and other petroleum products, you're looking at a facility that generates billions in revenue annually. Russia depends on this income to fund its military operations, which makes Ust-Luga far more than just another industrial complex. The crown jewel of this port is the Novatek gas processing facility, a massive cryogenic operation that processes 45 billion cubic meters of gas each year. This complex takes raw gas from Arctic fields and separates it into valuable components like ethane, propane, and butane. The equipment alone cost over $2 billion to build, and replacing it would take years. Russian engineers designed the entire facility to withstand earthquakes and Arctic storms, surrounding it with multiple layers of air defense systems. Military planners in Moscow repeatedly called it untouchable, positioned too far from Ukraine and too heavily defended to ever face a serious threat. But Ust-Luga became something else after international sanctions hit Russia hard. The port transformed into a central hub for what experts call the shadow fleet, tankers that move sanctioned Russian oil and gas without proper documentation. These sails fund the war machine, purchasing weapons, ammunition, and military equipment. Every day, this port operates at full capacity. Russia earns approximately $12 million in export revenue. Disrupting operations here doesn't just damage infrastructure, it directly impacts Russia's ability to sustain its military campaign. Ukrainian military strategists identified this vulnerability months before the November strike. The distance presented a massive challenge, requiring drones to fly nearly 1,000 kilometers through some of the most sophisticated air defense networks in the world. Russian forces had positioned S-400 missile batteries, Pantsir systems, electronic warfare equipment, and conventional anti-aircraft guns throughout the approach corridors. They had spent years building these defenses specifically to prevent exactly this type of long-range strike. Yet, Ukrainian operators saw an opportunity that others missed. 15 UJ-26 Beaver drones crossed into Russian airspace, flying low and fast through the pre-dawn darkness. These were not commercial quadcopters adapted for combat. Ukrainian engineers built them specifically for long-range penetration missions using carbon fiber and fiberglass, materials that reflect only 10% of radar signals compared to metal aircraft. On Russian radar, they appeared smaller than seagulls, making them extremely difficult to track. The first threat came from a Russian patrol boat in the Gulf of Finland tracers, from a 14.5mm machine gun lit up the sky as 3 Agla-S missiles launched. Designed for helicopters, these shoulder-fired missiles struggled to hit the small wave-skimming drones. 2 missed entirely, and 1 struck, turning a drone into a brief fireball over the Baltic. 14 continued toward Ust-Luga, just 40 kilometers from the coast next. An S-400 battery activated its gravestone radar. The system, costing billions and firing missiles worth millions, switched from passive search to active targeting. The drones dove to 10 meters above the water, and the first 2 48N6DM missiles tumbled into the sea because the control fins stalled at steep angles. The battery switched to Agile 9 M96E2 missiles with gas thrusters, capable of extreme maneuvers. They destroyed 2 more drones, but the explosion created false radar returns that concealed the rest. 4 Pantsir systems covered overlapping zones around the approach path. When the first Pantsir fired, the drones performed a wagon wheel maneuver, spiraling while advancing, which confused the missile's targeting system. Switching to twin 30mm cannons, the Pantsirs unleashed 5,000 rounds per minute. 4 drones entered the kill zone, only 2 survived. 9 drones continued toward the port, even as alert signals lit up 14 other command centers across western Russia. Every available air defense battery was now engaged, leaving no reinforcements for Ust-Luga. As the survivors neared the coast, fog reduced visibility to 30 meters, rendering thermal imaging nearly useless. Russian forces activated GPS spoofing, and 2 drones veered into the water. The remaining 7 relied on inertial navigation systems using gyroscopes and accelerometers, ignoring the false signals. They pressed on through tracer fire and electronic interference toward their target. By the time they reached Ust-Luga's outer perimeter, only 2 drones remained operational. Russian forces had fired dozens of missiles and unleashed thousands of cannon rounds. Despite overwhelming odds, these 2 drones were moments away from delivering a decisive strike and proving the power of asymmetric warfare that military analysts worldwide are still studying. Each UJ-26 Beaver drone costs about $35,000 to produce, while the S-400 missiles fired at them cost $2 million each. Even if every Russian missile had hit its target, the financial balance would still favor Ukraine. This illustrates a new reality in modern warfare, where expensive traditional defense systems struggle against waves of inexpensive, expendable weapons. At Ust-Luga, Russian crews fired over $20 million in missiles to destroy 13 drones worth just $455,000. The math is overwhelmingly against Moscow. Ukraine's domestic drone industry now produces roughly 200,000 units per month, with targets set at 2.5 million annually by the end of 2025. These systems are not overly complex or time-consuming to develop. Engineers shorten design cycles from months to weeks by integrating rapid battlefield feedback. When operators identify weaknesses or suggest improvements, factories can implement changes in days. Traditional military procurement often takes years to achieve what Ukrainian workshops now accomplish in a single month. The economic advantages matter tremendously, but the real story lies in how those final 2 drones actually executed their terminal attack against one of the most defended targets in Russia. The last 2 Beaver drones descended to just 3 meters above the Baltic waters as they approached Ust-Luga's massive tank farm. Water spray coated their camera lenses, turning video feeds into useless gray static. The operators in bunkers near Kiev were flying on GPS coordinates alone, watching basic telemetry update every 2 seconds through satellite links. The 2-second satellite lag made precision flying nearly impossible. When operators commanded a turn, the drone had already traveled 20 meters before receiving the signal. They had to fly by prediction, constantly calculating where the drone would be, rather than responding to where it was currently. One operator described it as playing a video game where the screen shows what happened 2 seconds ago while you try to navigate through narrow gaps at high speed. The mental load was immense, requiring operators to maintain perfect spatial awareness while compensating for delays that would crash any conventional aircraft. Russian security forces deployed water cannon trucks to intercept points throughout the facility. These industrial pumps could punch through wooden walls at 50 meters with enough pressure to snap propeller blades like twigs. One drone flew directly into a water stream and tumbled onto concrete, its warhead intact but completely harmless. The final Beaver adjusted course, its thermal camera momentarily locking onto the unmistakable signature of the cryogenic processor. The massive tank read -163 degrees Celsius, colder than anything else in the port and clearly visible on infrared sensors. The operator switched to manual control despite the satellite delay. The drone had 12% battery remaining, enough for maybe 90 seconds of flight. It traced a weaving path through the infrastructure, each turn burning precious power, as security forces fired rifles and shotguns at the sound of its motor. One shotgun blast shattered the camera completely, leaving the operator flying on last known position and dead reckoning alone. Russian emergency protocols had activated when the facility's automatic safety systems detected uncommanded aircraft approaching. The response was supposed to prevent catastrophic damage by venting thousands of cubic meters of methane and ethane to reduce tank pressure. Instead, this created an invisible cloud of perfectly mixed flammable gas hanging across the entire complex, waiting for any spark to ignite it. The defenders had accidentally set up ideal conditions for maximum destruction. The battery died completely, with the drone 50 meters from target motors stopped instantly. But 40 kilograms of aircraft traveling at 15 meters per second carries substantial momentum. It glided in eerie silence, a ballistic projectile following Newton's laws, and struck the fractionation column's base exactly where the operator had aimed. For one heartbeat, nothing happened. Then, the 20-kilogram thermite-enhanced warhead ignited, burning at 2,500 degrees Celsius. Thermite combines aluminum powder with iron oxide in a reaction that can't be extinguished with water or foam. Once started, it burns until the fuel is completely consumed, hot enough to melt through steel in seconds. The initial explosion was relatively small, just a white-hot flare that burned through the column's steel wall in 2 seconds. But superheated metal sprayed into the pressurized vessel, instantly vaporizing liquid hydrocarbons inside. The pressure spike ruptured adjacent pipes, releasing more flammable gas into the vented cloud. Then everything ignited at once. The fuel-air explosion expanded at 3,000 meters per second, a crushing overpressure wave that shattered every window within a kilometer. The fireball rose 200 meters, brilliant orange against the morning fog. The facility suffered what engineers call a BLEV, a boiling liquid expanding vapor explosion. When pressurized, liquefied gas suddenly depressurizes, it expands roughly 600 times in volume almost instantaneously, creating devastating explosive force. Each ruptured vessel caused adjacent vessels to fail in a cascade of destruction that consumed the entire $2 billion complex within minutes. The fire burned for 6 days. Visible from satellites and clearly seen from the Estonian border 50 kilometers away. This strike marked Ukraine's deepest successful strike, yet Ust-Luga represents a permanent shift in how conflicts will be fought for the foreseeable future. Expensive precision weapons won't disappear, but they'll increasingly share the battlefield with swarms of expendable, AI-enhanced drones manufactured in enormous quantities. The side that can produce more, iterate faster, and adapt quicker will hold decisive advantages regardless of traditional military metrics, like aircraft carriers or tank divisions. Ukraine is running the world's most consequential military test laboratory, and everyone is paying attention to the lessons being written here. So, what do you think about this dramatic shift in modern warfare? Do you believe cheap drone swarms will really replace traditional military hardware, or will defenses eventually catch up? Drop your thoughts in the comments below, and please give this video a thumbs up if you found it informative. Subscribe to our channel for more detailed breakdowns of military technology and strategy. Until next time, stay informed.